Hi folks, and welcome back to Math with Captain Rod. The purpose of this video here is to demonstrate how to find area via integration using parametric equations. So what we're going to do is we're going to take a look at the function y equals x cubed over the interval 0 to 1, and again these are over x values. We're going to look for the area under the curve. So I've already went ahead and drawn a sketch. If you were working this problem from scratch, the first thing I would expect is just at least a rough sketch here. So y equals x cubed looks, roughly something like this. Usually rough sketches are enough for setting up integrals. Now if we go out to 0, 1, all right, so x would be a 1. This would be the point 1, 1. I'm getting the second one by 1 cubed. All right, now in this example, the parameterization was given to us, x equals t squared and y equals t to the 6. So these are things that typically you would get to choose. If you were not given these, you would typically choose a parameterization for x, but then y is defined by some function. That would dictate your equation for y. But anyway, moving on. So I'm going to take the parameterization given. When finding an area, the first thing you always do is draw an area element. And that's true whether or not you're going to be using parameterized form or any other method. So I'm going to go ahead and draw my differential element in red. Okay. Boom, there's my differential rectangle. And you may choose to give it kind of a finite looking width if you want, which is perfectly fine. In theory, these things are infinitely small if you label this with a differential width, dx. Now again, your labeling of this is going to depend on how you're typically going to try to attack it. I'm going to attack it just using standard integration methods. If we were to try to work this numerically with a computer, I would label this delta x because delta x is a finite measurable width. dx is infinitely small. All right. Next thing we do is I'm going to write out an equation here for the area of this rectangle. The length is equal to the function value, which is y, and the width is dx. So again, I'm going to leave this in red so that the viewer knows this comes directly from this red rectangle. But now to do the work, I'm going to switch to black. Now, the total area we get by integrating this expression y dx. And there's actually 3 different choices here now of variables we can do this with. And I would like to talk about all of them for just a moment. One, we could take this integral and shift it all the way to x's. And what would that look like? I'd replace the y with x cubed. So we would have dA is going to equal x cubed dx. And then the limits would run 0 to 1. And that's probably the fairly standard calculus approach to that problem. The second thing we could do is we could shift this integral over to y's, believe it or not. And it might look something like this. dA is going to equal y dx. And you can get your dx from here. dy dx is equal to 3x squared. And let me write that off to the side. dy dx is equal to 3x squared. And if you solve that for dx, you'd get dy over 3x squared. Then you'd use the function to eliminate the x squared. Then you'd have an integral over y, and you'd integrate that 0 to 1 vertically. And of course, the point of this problem is to shift this integral over to a third variable, t's. And what's that going to look like? And I'll go ahead and do that right below. So what that's going to look like is this, first line. Okay, y as a function of t is t to the 6th power. dx we can get from over here. If you calculate dx dt, you get 2t. So dx is equal to 2t dt. Therefore, our area we can now write as an integral over t. The 2 is constant. I guess we'll bring that out in front. And then t to the 7th power dt. Now, our limits of t are not given directly. We're going to get them from right here. So if x is 0, t is 0. And if x is 1, t is also 1. So this is an integral from 0 to 1, 2 times t to the 7th dt. So this is going to equal, let's see, 2t to the 8th over 8, evaluated 0 to 1, which is 2 over 8 minus 0, which is 1/4. So I hope that this video helps demonstrate how to find an area over using parametric equations. Have a great day.